Hey guys, we're going to be talking about solving rational equations. So these are the type of equations that look similar to the ones below. So there are a ton of different ways to go about solving these types of problems. However, I'm going to walk you guys through two of my favorite methods. So with these types of problems, we have variables in the denominators, which is why they're called rational equations. However, we can also sometimes have variables in the numerators. But having variables in the denominator of a problem makes things pretty difficult for us to solve. So our goal for both methods actually is to get the variables out of the denominator of our equations. So in order to do this, step number one, we are going to factor everything we possibly can out of the denominators. Boom. So in this one, we weren't able to factor too much, but that's okay. So you may be asking yourself, well, do I have to factor the numerator also because there's a 5 there that I could factor out? No, not necessarily, unless it would help you pre-simplify one of your fractions in this equation. Otherwise, you don't have to worry about the numerator yet, just the denominators. So we have everything factored out. Step number 2 is going to be finding a common denominator. So if I take a look at all the denominators, I notice that I have a single x in my first two fractions, so that is going to have to be part of my common denominator. I also notice that I have an x minus 4 over here. That is going to need to be part of my common denominator because I need to include every single part of my common denominators. And then I changed my 1 into a fraction as 1 over 1, so I could figure out what the denominator of this guy is, which is just a single 1. And that's totally fine. If I have 1 times anything, it's itself, so I don't have to necessarily worry about that when we are looking at just figuring out what the common denominator is. So our common denominator is x times the quantity x minus 4 for this specific problem. So the reason we found that is because we want to be able to cancel out our denominators so that we no longer have to deal with fractions, which would be awesome. So in order to do this, we are going to multiply our equation by our common denominator. And when we multiply an entire equation, we have to distribute, so we are multiplying every single term in our equation by our common denominator. Boom, like so. So I have effectively multiplied every single term individually by my common denominator, and now we get to simplify. Alright, so when we are simplifying fractions, we are looking to create giant ones so that we can cancel out and reduce our fractions. So if I take a look at my first term, I notice I have a single x in the numerator and the denominator. Those can make a giant 1 and cancel out. I also have an x minus 4 in the numerator and denominator, make a giant 1, cancel out. So for my first term, I am left with 5x plus 5. Alright, my second term, both of those have a single x that I can create a giant 1 with and cancel out, so I am just left with this negative 1 times the quantity x minus 4. Alright, and then finally, I don't have anything to cancel out of my last term over here, so I just have 1 times x minus 4, which 1 times x is just x, so I have x times the quantity x minus 4. Alright, so this is starting to look a lot better. I don't have any denominators or any variables in any denominators, so it's going to make my life a lot easier to solve this problem. So my final step is to just solve for x. Part of the reason why I did not pre-multiply things out, pre-distribute, is because of this tricky negative right here. I need to make sure when I'm starting to simplify this that I distribute out the negative 1, not just a 1. So that's going to have a huge impact on my problem. So if you ever have a minus sign or a negative, always make sure you are correctly distributing that. So we have 5x plus 5 minus x plus 4 equals, and I can distribute this guy as well, so we get x squared minus 4x. Alright, just in terms of solving, I notice I have an x squared term, which means I have a quadratic which means I am going to have to use one of my methods on solving quadratics. So we can factor, we can complete the square, we can quadratic formula. My recommendation is factor if you can possibly factor. So I'm going to get all terms on the same side. I like having my a value positive, so I am going to get all terms to the right side of this equation. Boom, like so. All right, for factoring, we can use the box and diamond method. If you forget what that method looks like or is or how to factor, please refer to our Factoring with Generic Rectangles video on our YouTube channel. Shout out to Wizard Knight Math. But we're going to go ahead and factor this guy really quick. So we have the quantity x minus, 9 times the quantity x plus 1. All right, using the zero product property, we get that x could equal positive 9 or negative 1. Now, what we want to make sure is that we don't have any extraneous solutions. So extraneous solutions happen when we solve for it, we get an answer, but when we plug it back in, we get something that does not work. And so you can go ahead and take the time, plug this back into your original equation. These two solutions, however, will work, and they are solutions for our rational equations. So this is one method to solving. Our second method goes over the same concepts, slightly different in nature, but the nice thing is it has the first two steps in common. So let's see what that looks like. All right, so in this one, we factored the denominators already. We found the common denominator already. Now here's where it's going to get a little different. Our third step, we are going to rewrite every single one of these fractions to have a common denominator. So we are going to multiply by whatever that fraction is missing to get that common denominator. And this will look as such. Boom. All right. Something to keep in mind. When you are trying to get a common denominator, we are multiplying both the numerator and denominator of the terms that it is missing. So our first term, we didn't have to multiply by anything since it had the full common denominator in it. The second term, we had to multiply by the x minus 4, numerator and denominator. We're multiplying by that giant 1 to keep the equation balanced. And the second term, we are multiplying by the x and x minus 4. So now we can see that all of our terms have a common denominator. So step 4, we are going to multiply the entire equation by the common denominator to effectively wipe it out. All right, so when we do this, we are taking our entire equation and we are multiplying it by our denominator, which in this case was x times x minus 4. So remember, multiplication and division cancel each other out. So really, when we're distributing this multiplication, we are canceling out every single one of our denominators with what we're multiplying by. So we have effectively wiped all the denominators in one fell swoop. So we are left with the 5x plus 5 minus 1 times the quantity x minus 4 equals our 1 times x times the quantity x minus 4. All right, here we are going to solve for x, which we did just a minute ago, so I won't re-go over this. But we know that the answer is x equals 9 or negative 1 for our two solutions. All right, so there are two ways on how to solve these rational equations.